Now let's move on to Pandas. And Pandas is a Python library that is used to analyze data. So the first topic we're gonna go over in Pandas is Pandas series. And a series is like a column in a table. It's a one-dimensional array and it can hold any type of data. Before we do anything in Pandas, we need to import it. Import Pandas as PD. And since we don't want to type out this whole Pandas word every time we want to refer to a function in the Pandas library, we type as PD. So let's run this. And now let's create our series. So x equals and now let's create our series. So we call PD what we imported Pandas as dot series with a capital S, and in brackets we type in the data keyword, and then we put our variable where we stored our list. So let's call out our series, and you see here we have the series. Let's look at the type, and you see it tells us that it's a Pandas series. We can also index, so let's say I want the 200 value. Let's call this out. And let's say I want this 300 value. I just call in the index number position. So x2, let's run, and you see we got the 300. We can also name our indexes instead of it getting the default numbers. So I'm going to create another variable with the index names. I know I'm supposed to be giving these capital letters, but it's just a tutorial. So let me create a new variable called new equals pd.series, and in brackets we want the data to be x, and we set the index to our days variable we just created. And now let's run new, and you see we renamed our indexes. We can access any value, so let's say if I want Friday, call in the new, and we put in between quotes, we put our index name. And let's run that, and you see we got the value. We can also access multiple values, so let's say I want Friday, Tuesday, and Monday. And then we have to surround this with block brackets. And let's run that. And you see we access multiple values. As you can see here, the data type is currently integer 64. We can change this by adding a third argument. So let me just copy this, paste it here. Then we could add set the D type to, let's say we want it to be a float. Now let's run that, and now you see the data type of our series, of the values in our series, is a float. We can also create series with dictionaries. So let me show you. So we're gonna create a dictionary. We're gonna set John to 5, Ron to 4, and then Sally to 8. Now let's run that. And when we're creating series with dictionaries or key value pairs, the keys is the index and the value is the data. So let's create a series from our dictionary. So pd.series, and we can put data equals D. And let's run that. And you see we created a series with our dictionary. We don't have to put the data equals. We can remove that. Let's press Shift Enter, and you see it does the same thing. So this is Pandas series. Now let's move on to Pandas data frame. And a Pandas data frame is a two-dimensional data structure like a 2D array or a table with rows and columns. So before we create our data frame, I put my index in the IND variable, my columns in the COL variable, and our data. And from what you can see here, our data will have 5 rows and 3 columns. So let's run this. And now let's create our data frame. So PD, remember we imported pandas as PD dot data and frame with a capital F, and we're gonna set our index to our IND variable. The data equals the data, and equals call. Let's save this into a variable. Let's call out our variable, and you see we created our data frame. Let's look at the type, and it should say it's a data frame. Now let's move on to a function called a setIndex. And the setIndex function can set an index using existing columns. So let's set column C to the index. Call out our data frame dot set underscore index. Put our brackets, and in between quotes we put column C. And let's run that. And you see now column C is the index. And you see by default that it dropped column C. So if we wanted column C to remain, let's copy this, paste it here. We would have to add the drop equals false argument. And now let's run that. And you see it kept our C column. But as you can see, let's call out our data frame. And you see the changes wasn't made to the data frame because we can add one more argument into our setIndex object. So let me copy this, paste it here. And now if we want our data frame to save these changes, we write in place equals, and we set that to true. And now let's run that. Now let's call out our data frame. And you see now the changes has stayed. Now let's move on to the reset index. So I'm gonna set the index back to 0, 1, 2, 3, and so on. So now let's call out our data frame dot reset underscore index. And in between brackets, we have to use the drop equals true argument because by default, the drop arguments is false. And we cannot reset an index with an already existing column. So let me just show you. All that, let's run. And you see we get an error. And it says you cannot insert C because it already exists. So we need to use the drop column argument. So now let's set the drop equals to true. And let's also set our in place to true. And let's run that. Let's call out our variable. And you see our index was reset. So that's Pandas data frame. One more thing we can do is read CSV files, export files, JSON files, and so on. So now I'm going to show you how to import a CSV file into a data frame. So now let's import our CSV. So I'm going to set x equals to pd.read underscore CSV. And in between brackets, and also in between quotes, we put the name of our CSV file. And the name of our CSV file is top 10 countries. So top 10 countries. And this file needs to be in the same file as the Python file that you're working on. Let me just show you pandas, rename. And you see it's in the same folder as the Jupyter notebook script that I'm working on. So let's run that. And now there's an error. Okay, I needed to add .csv at the end because it's a CSV file. And let's run that. And now let's call out X. And you see we loaded our file into Pandas data frame. So now let's move on to selecting data in Panda. So the first thing we have to do is import Pandas. Let's run that. And let's import our data. So I'm going to call our variable countries. pd.read underscore CSV. And the name of our file is top 10 countries .csv. Misspelled countries. Let's call out our countries variable. And you see we put our CSV inside our countries variable. So now let's go ahead and select one column. So let's say I want to select the region column. I'm going to go countries and then brackets and then colon. I'm going to put in the region column. And now let's run that. And you see we get our column. Another way we could do this is putting a period and then our column. Let's run that. And you see we get the same thing. The only thing about using this method is that we can't do columns that have names with space in between them like this. For ones like this, let me just show you. We'll get an error. For columns like this, we need to surround it with brackets and in single or double quotes. Oh, I need to remove this period. And let's run that. And you see we got our column. Let's copy this. And look at the type. And you see that it is a series. A single column is a series. And a data frame is a collection of series. So now let's move on to selecting multiple columns. So let's call in our data frame countries, and inside of 2 block brackets we can put in a list of our columns. So region, country, let me just paste let me see what other columns. Let me just get the date. I need another block bracket here, and let's run that. And you see we get multiple columns. We can also select rows by the index position using the iloc function. So countries dot iloc, and in the block bracket we put the index position. So let's say we want 4. And let's run that. And you see we get the 4th index. We can also slice. But first let me just call in our data frame. So let's say I want to slice from the 5th index down. I'll simply put 5 colon and leave the other side blank. And let's run that. And you see we got from the 5th index down. We can get from the 5th to the 8th. Oh, the reason why we don't get 8 is because the stop argument is exclusive. So if we wanted 8, we would have to put 9. We can also index rows and columns. So countries.iloc 6 to, And you see it's Africa because it's in the 6th index, 0, 1, 2. It's in the 2nd index. Let me just remove this so we can see our data frame. And we can slice rows and column. So let's say I want from the 2nd index, and I want columns 0 from 1 to 0, 1, 2, 3. Let's run that. And you see we get from the 2nd index down, and we get from column 1, 2, 3. And we know the 3 is exclusive. The loc function requires labels and names. So let's say countries.loc. We can't put index positions, but we have to put the names. So I'm gonna say I want from index 3 to 6. So it's gonna bring 3 to 5. So 3 to 6. And then I only want the region column. So let's put the region. Now let's also put the population. Comma. And now let's run that. So the loc function requires label names. It doesn't accept index positions. So now let's move on to conditional selection. Let's call in our countries data frame. And let's say I only want to return the rows where the region is Asia. So I would call in my variable, and in between block brackets, I'll call out our countries, our region column, and then I'll set that equals to Asia. And let's run that. And you see we only got the rows where the region is Asia. We can also do Africa. Let's run that. And you see we get one row because Africa is the only region in this table. We can combine multiple conditions using the and the or operator. So let's do that. So I'm gonna create countries, and in block brackets, I'm gonna take this, then I'm gonna put the and sign, and then I'm gonna say I want where the countries column population is more than a certain amount. So I'm gonna add countries population is greater than, let me say 300 million. And first we need to surround the two statements with brackets. This one is already surrounded with brackets. And now let's run that. Let's see what's wrong. Oh, the P is capitalized because in our column here, it's a capital P and I put a lowercase. So let's run that. So Africa's population is not more than whatever we're asking for here. So let me put Asia. And let's run that. And you see we bring up the rows that satisfies our conditions. If we wanted to use the or instead of the and, we use this, and let's run that. And then you see it brings us the values where the region is Asia or the population is over 300 million. We can add additional filters, like if we only want certain columns. At the end of here, we open two block brackets. The one inside is our list, and we'll put a list of our columns. And let's say I want the rank country/dependency, but I'm gonna copy this. Control C, in between quotes. And now let's run that. And you see we get the columns that we asked for. We can also select rows that match a list of values. So let me call our countries variable. And let's say I want to bring the rows where the region is Asia and Americas. Let's call it our data frame, and in between brackets, we call out our region column. And then we're gonna use the isIn method. And it will take the list of the rows of Asia and Americas. So create this list, Asia, Americas. And let's run that. Oh, we need to capitalize because Americas is with a capital A, Asia is with a capital A. And let's run that. And you see we brought the rows where the region is only Asia and Americas. Some few other things. Let's call out our data frame. And let's say we only wanted to bring the top 5 rows. We would write countries dot head in brackets. And let's run that. And it brings us the top 5 rows. Let's say we only want 2 rows. We would put it here. And then let's run that. If we wanted to bring the last 5 rows in our data frame, we write countries dot tail, put in brackets, the default is 5, the last 5. And you see here it brings in the last 5. Let's say if we want the last 3, it brings the last 3 rows in our data frame. Now let's move on to data manipulation in Pandas. And before we do anything with Pandas, we have to import it. So let's import Pandas. And let's put a CSV into our data frame. pd.read_CSV. And the name of our file is countries.csv. This file will be available for you to download if you want to follow along. So now let's look at our data frame. Oh, the name of our file is top 10 countries. See it here, top 10 countries.csv. Now let's run that. And you see here we have our data frame. To check the shape of our data frame, you could just write data frame shape. Let's run that. And you see it's 10 rows and 6 columns, like we see up here. To check the data types, write df.dtypes. Let's run that. And you see the data types of the columns in our data frame. If we want to check the columns, we could simply write dataframes.columns. So now let's move on to renaming a column. And to change the column name in the data frame, we use the rename method. So let's look at our data frame. So let's change the name of this column here. So we say data frame.rename. And in between brackets, we put the columns and we put it like a dictionary. So we put our countries / dependency. And then we put what we want to change it to. We only want to change it to country. And then we want to set in place to true so the changes stays in our data frame. And now let's run that. And you see the column name was changed. To delete a column, we use the drop argument. So let's call our data frame .drop. And let's say we want to drop the date column. In between braces, We put column equals date and set the in place to be true. Now let's call our data frame. Let's run that. And you see the date column was deleted. And let's move on to add a column. Let's add a column called population in millions. So we rally our data frame and then we put what we want the name of our columns to be. So population in millions. And what we want this column to have, we want to divide the population column by 1 million. And then let's round it to 2 decimal places. So let's put our data frame. We want our population column. And we want to divide that by 1 million. And then we said we want to round it by 2. And the round takes 2 arguments. It takes whatever we want to round. And the next argument is the decimal places. So we want to round it by 2 decimal places. And now let's run that. And you see we created our column, which divided the population by 1 million and rounded it by 2. Let's create a column that joins 2 string columns or 2 object columns. Let's create a column called country/region, and we want to put the countries / the region. So let's create our column, and we want country/region. And what we want in that column, we want the values in the country column. It's a capital C. Then we want to add a slash, and then we want to add the region column. And let's look at our data frame. Oh, we need to put this in between quotes. So now let's run that. And now you see we created our column that joined the values in the country and region column. So now let's change the data types of a column. Now let's check the data types of the column. And you see the percentage of the world is an object. So let's change it to a float. But before we do that, we need to remove the % sign. So let's create a function to remove the % sign. And then we want to return X, and we're gonna do a negative step value. So now let's run that. Let's call in our function. Now let's put a value in our column. And let's run that. And you see the % sign was moved. So now let's use the apply function to apply it to our column. So let's call our percentage of world column. Let me see that I'm spelling it right. We're gonna write dot apply, and then we wanna apply our function that we created. Now let's run that. And you see it removed the % in the column. So now let's assign it to our column. We call out our column. And we set that equals to what we did here. Now let's call our data frame. And now you see the percentage was removed. Now let's check the data type. It should be the same. And we see that it's an object. So now that we remove the % sign and it just has the decimal, we can change this column, its data type, into a float. So let me just copy this. and we set that equals to the column, and then we use our asType function, and then in brackets we write float. So now let's check the data type, and you see the data type for the percentage of the world column was changed. So now let's deal with datetime columns, but before we do this, let's load another CSV file. And the name of our CSV is cyclohires.csv. We need to put it in between quotes. Now let's call out our variable. And you see we get our data frame. I want to drop this column. df2.drop columns, and we set that equals to the name of our column. And we want to set the in place to true. Now let's call out our data frame, and you see the column was dropped. Let's look at the data type, and we see that the day is an object, so let's change that into a datetime data type. So one way we could do this, let's set our variable, and we set that equals to, we want our day column, and then we use the asType function, and we want the datetime data type. So now let's run that. Oh, we actually need to, because we want to change the column. Let's remove that period. And now let's run that. And now let's check the data type. And you see we changed the data type for our day column. It was an object, now it's a datetime column. Another way we can do this is with the toDatetime function, and we won't get this error. Now let's set that to pd.to_datetime, and in between brackets we put our column. Now let's check the data types. It will do the same thing, but without the error. So it's better to do it this way, because you see we get this little warning message. So to change a column into a datetime data type, you should just follow this way. We can use the datetime model to convert a datetime data type to a string. And when we do that, we can display the dates as months or year. But first we need to import datetime. So let me do that. And let's run that. And now let's look at our data frame. Actually, our second data frame. And let's say we want to extract the month and the year from this date. All right, call it our column, day, dt.strf time, and in between brackets we put a percentage and B, and the percentage B is the format code for the month, percentage Y is the format code for the year. Let's run that. Oh, we made a mistake here. It's DT, not DF, datetime, because we imported it as DT. Now let's run that. And you see we got the month and the year. So now let's add this into a new column, and we're gonna call our new column month/year. And we're gonna set that equals to what we just did here. Let's copy this, paste it, and now let's look at our data frame. And you see we made a month and year column, and we extracted the month and the year from our day column. So now let's move on to sorting the values, and let's sort the values by the number of bicycle hires in the descending order. Let's call out our data frame, and then we use the sort values function, and in brackets we want it by the number of bicycle hires. I'm just gonna copy this, and by default it comes in ascending order, but we want it in descending order, so we have to write in our ascending argument equals false and set the in place to true. And now let's look at our data frame, and you see it's sorted in descending order by the number of bicycle hires. If we want it in ascending order, we just remove the ascending argument, and let's run that, and you see now it's in ascending order. If we want to see the first 5 rows in our data frame, write df2.head, and by default it brings up 5. If we want 2, we just put in the number in between the braces. If we want the last 5 rows, we use the till method, and let's run that, and see we get the last 5 rows in our data frame. If we want the last 3, we just put the value in between the brackets. One more thing I'll show you, df2, we could transpose the rows and columns, which simply means just flip it. So let's write our data frame dot transpose, and let's run that, and you see we flipped our columns and index. So now let's move on to data aggregation and grouping. But before we do that, I want to do some data manipulation so we can get the data frame how we want it. So we're going to read our CSV file. And you see we loaded our data frame. So let's drop some columns. I want to drop the percentage of the world and the date column. So you see the drop columns equals to, said I want this. I'm just going to press Control C to copy it and Control V to paste. And the next one will be date. And we want to set the in place to true. And let's run that. Let's look at our data frame. And you see we dropped the columns. Let's rename the country/dependency to country. So c.rename columns equals, I'm going to use a dictionary. Let me just copy this. And we want to change that to country. And set the in place equals to true. So it saves our changes, and let's look at it. And you see the column has changed. Let's see the data types. So let's change the column and region column into a string data type. So C, and in between double block brackets, we put the name of a column country and the region. I'm gonna set that equals to, just gonna copy this and put it on this side. Control C to copy, Control V to paste. And then we use the as type function and we say we want it to a string. And now let's look at our D types after that. Here, let's run that. And you see it's been changed to a string. So let's create a column called subregions, and I'm gonna paste some values. Put it here. And then we're gonna add this to our data frame. So our C, and our column name that we're gonna add is subregion. It only needs one bracket. Then we set that equals to what we stored in this variable here. And now let's look at our C, our data frame, and you see we added the subregion. Let's look at the data types. Let's run that. And let's change the data type for subregion from an object to a string. So I'm gonna copy this. And I'm gonna paste this again. And I'm gonna add as type string. Let's see our data types now. And you see we made the changes. Let's use the reindex function to reorder our columns. So set C equals to C dot reindex. Let's set our columns equals to, let me take a look at our data frame. And I want subregion here. So let me just pass it in as a list. Rank, country, the population. Now let's look at our data frame, and you see we made the changes. Now we can move on to aggregation functions. So let's perform some aggregation on a numeric column, and let's do it to our population column. So if we wanted the mean, simply call in our column population dot mean, and let's run that. And you see we get the mean. We can also get the max, the min, the sum, standard deviation, and also the count. We can also use the describe method to return all descriptive statistics. So I'm gonna just copy this. And here I put describe. And you see we get all the descriptive statistics. We can also apply it to our data frame, and it will only bring up the descriptive statistics for the numerical columns. So there's only 2 numerical columns in our data frame. We can apply the max and min to a string column, and it will bring the first string that's in alphabetical order. So I'll just look at this. So let's say country, and we want the min. Let's try the subregion. And you see we get Central America. So you see here it brings in Central America because in alphabetical order it's the first. If we bring the max, we get Western Africa. Now let's move on to the unique function, and it returns a list of unique values for a column. So let's say we want the unique values for the region column. We call out our column and our unique function. Let's run that. And you see we get the unique values, which is only Asia, America, Africa, Europe. And you could see in these columns, those are the unique values. We can bring the number of unique values using n unique. Oh, I meant to copy instead of, I'll just type it again. C dot region, and we want n unique. And let's run that. And you see we get 4. And we just copy this and do the unique. There you have it. Now let's move on to the GROUPBY function, and it is used for grouping values in a column. So let's look at our variable. Let's look at our data frame, and let's find the total population for each region in our data frame. We will do this by c.groupby, and then in brackets, the by keywords, and we said we want the region column, and then we're gonna find the sum. Let's run that. And you see it grouped our data frame by the region, and it brought us the sum of the numeric values. Let's say we want to remove the rank column. I'll just put C, and in between double block brackets, we put the columns that we want to see. And we only want to see region and population. And then we're going to call our GROUPBY keyword. Then in between brackets, we put region. Then we want the sum. And let's run that. And you see it only brought the region column and the population column, and it grouped by the countries in the region column. We can group by multiple columns by passing it in as a list in the GROUPBY argument. So let me just copy this part. And then I'm going to add sub-region here. Put a comma here. And then we want to group by region and sub-region. So it said equals to region and sub-region. And we have to surround this by block brackets. And then let's add sum. And let's run that. And you see it grouped it by both the region and the sub-region. And it found the sum of our regions and sub-regions. If we want, we can add another column, the min and the max, which brings in a min column, which brings in the minimum values, and the max column that brings in the max. So let's just copy this so we don't need to retype. Press Ctrl C and Ctrl V. And instead of this sum, I'm going to call our agg function. And in between the list, we put the min and the max. And let's run that. And you see we grouped our data frame by region and sub-region. And we applied multiple aggregate functions. So this is aggregate functions and GROUPBY. Now let's move on to data cleaning. And here I created a data frame, a dirty data frame that we can practice cleaning with. So this is the data, and I created a data frame, and I set the data equals to, I put up my data into a zip function, and then we put that zip function into a list, and then we set the columns into equals our columns here. So now let's run that, and you see we got our data frame. So one thing we should do is check our columns for white spaces. So let's look at our employee column. You have .employee, and let's run that. And you see we have plenty white spaces before and after. One way we can fix this is to create a function and pass in the strip method into our function. So let me just show you what I mean. Employee, set that to dfEmployee.apply, and apply takes a function, so I'm going to create a lambda function, lambda x, and what I want it to do is strip, and this is going to strip all the white spaces. And let's run that. Let's look at our employee column, and you see it removed the white spaces. We can check for null values in a data frame by using the isNull function, df.isNull, and then we have to see the sum of those values. And let's run. And you see we have one null value in position and two null values in salaries. And here you see it. One way we could deal with null values is by dropping the rows that contain them. So df.drop NA. Let's run that. And you see it drop the rows with the null values. If we don't want to drop all the rows, like let's go back here. Maybe we only want to drop 2 rows of null value. We should set the threshold to 2. And we set the thresholds inside of our NA function. So thresh equals 2. Let's run that. And you see it only removed 2 rows that has null values in our data frame. If we want to drop a column with null values, we set the axis to 1. So let me just look at our data frame again. And if we set let me just copy this. And if I set the axis to 1, it's gonna drop all the columns with null values. Let's run that. And you see the position and salary had null values, so it will only bring up the employee column. Let me look at that data frame again. We can also replace the null values with a specific value. So let's write df.position.fill NA. And I want to fill all the NA values with lawyer. Actually, I'm filling all the null values in the position column with lawyer. Put a Y here. And then I want to set the in-place to true, so it stays equals true. And let's call out our data frame. Let's run that. And you see it filled in the null values with the lawyer that we specified. Next, if we want to fix wrong data. So let's say we want to change lawyer to accountant. Let me just copy this part here. Control C, Control V. So inside of the column position, we want to make the changes. And we want to replace the lawyer. And then we're going to put accountant as the next argument. So we're going to change from lawyer to accountant. And now let's call our data frame. Let's run that. And you see lawyer has been changed into accountant. So this is some basic data cleaning in Pandas.